Hello all. In this video I am going to demonstrate Arduino Uno based frequency meter. So this is my Arduino Uno based frequency meter. I am reading 50.01 Hz currently. So as you can see, let's go to the circuit first. The Arduino Uno based frequency meter. The circuit basically comprises of the three parts. First part is the zero crossing detector. First part is the zero crossing detector. The zero crossing detector consists of an op-amp LM324. So this is the op-amp LM324. The pin number 2 of the op-amp is the negative pin, it is grounded. Okay, and the op-amp is supplied with plus 5 volts DC power supply. The output of the op-amp is fed to the Arduino Uno board. Okay, now the main thing is that the input voltage sample is taken from a transformer. I am using 220 volts 50 Hz transformer. So this is a step down transformer. It is dropping down the voltage to 6 volts DC. I'm sorry, it is dropping down the voltage to 6 volts AC. So 220 volts AC I am dropping down to 6 volts using this transformer. After the transformer I am using a rectifier 1N4007. So I am converting the AC signal into a DC signal and I am feeding it to the voltage divider network. So this 10K potentiometer on the top, this potentiometer is used to adjust the voltage, and this one is a fixed resistance. So the output of this potentiometer is fed to the LM324 comparator as a zero crossing detector. So the waveform is being analyzed here and I am getting a perfect square wave at the output. So this will be my output waveform. So as we can see, this is my input waveform and this is my output waveform after the zero crossing detection. So the output from the pin number 1 of LM324 IC is fed to Arduino Uno. I am using pin number 2 as the input reading pin. So the signal is read by pin number 2. The software inside the Arduino will read the frequency and it will display the frequency using the pin number 11 and pin number 12 to a shift register based 7-segment display board. Okay, the 7-segment display board finally will display the frequency. However, the frequency will be shown in the serial monitor also using PC based interface. This is used for debugging the software or analyzing the software. So now I am going to show the main circuit. So as you can see here, this is my shift register board. So this is the shift register board. As you can see, this is the shift register board with 7-segment displays here and the shift register ICs are below. There are too many wires as you can see here. Now the shift register ICs are a bit visible. See inside, yeah. So CD4094 shift register I am using. So for 4 7-segment displays there are 4 shift registers. So this is my circuit. Okay, so the shift register board is the final output actually. So first I will start with the input again. So the input signal is being fed to the zero crossing detector. The main line signal is fed to this transformer first. The output of this transformer is fed to this zero crossing detector. I have made a detailed video about this zero crossing detector before, so I would recommend to see that video for those who didn't watch the zero crossing detector circuit. So the output of this zero crossing detector is fed to Arduino Uno. As you can see here, it is fed to the pin number 2 of the Arduino Uno. This is the orange wire. Oh, okay, so this is the zero crossing detector output, and the clock and data signal from the Arduino Uno output is fed to the 7-segment display boards. See, this is the white wire is the data wire and black wire is the clock wire. So both of them are fed to the Arduino Uno 7-segment display board, the shift register based 7-segment display board. So this is my power supply for the circuit and this is the circuit from far. Okay, now we can see here the reference frequency is 49.96 Hz, 49.97 Hz, and the frequency here is 50.049.89 Hz. There is a change in the frequency, 49.91 Hz. Okay, now we will look into the software a bit. I will prepare the PC terminal and show the software model. So as you can see here, in the software model I am using the pulse in command. as you can see here, this is the pulse in command. So pulse in command will read the signal from the pin number 2. Okay, and it will measure the duration of the command. The serial port is used in order to print the duration for my own debugging. The output value is scaled using this map command. See, this is the map command. It is displaying the output value. Okay, so the output value is between this 45 and 55 hertz. The frequency meter works between the 45 and 55 hertz. So this is the main frequency block. This is the main analyzing block for this frequency meter. Now I am going to show you the main software. So as you can see here, this is the main software. So these are the variables initializations. Okay. So now this is the main loop. Here I am using the pulse in command. The same pulse in command I am feeding it to the pin number 2, and when the pin goes high, the counter starts counting and the scale is mapped, and finally the output variables are displayed using this block. As you can see here, whatever the counting is there, the finished counting is converted into different numbers, and they are shown and they are fed to the shift register block. The final shift register block, you can see here, it is showing shift out, data pin, clock pin, MSB first, and the value to be shown. Okay, so like this the software behaves. So this is all for today. Thanks a lot. Thanks for watching. I would like to show you the model once again. So this is my frequency meter. Once again I am going to show you. So thanks a lot. Thanks for watching.